Here we go, guys. Today's hashtag shout out to Monty. Monty loves math. Whenever you see Monty, tell her she's in today's hashtag. All right. So these questions, let's get right into it. It's a short period. These questions are coming, most of them are coming right from Delta, questions that we were having issues with. So let's look at number one. It says find dy dx in terms of x and y. So just make a note that we know that this is the same thing as x plus y to the 1/2 power. So when we're taking a derivative, this is implicit. So I'm going to go 1/2 parentheses x plus y to the what power? Negative 1/2. And I'm not done yet. Times the derivative of the inside. The derivative of x is 1 plus dy dx. And it looks like we're done with that part. Equals. Perfect. And you're done. That's calculus. Or you're done with calculus. The rest is all algebra. So what I would do here, guys, I think Delta likes to leave it alone. And they, I would leave this in the numerator, that part right there. So 1 plus dy dx over, and then that 2 comes to the bottom because it's like a fraction there. And then this negative half means square root of x plus y like that. Equals, I don't see any errors. Here's what I see right now. Are we still okay? Okay. So now, because I'm trying to solve for dy dx, I need to get rid of that denominator. That's a plus symbol right here. So I'm going to multiply it. Good job. 2 square root of x plus y. Whatever I do to one side, I do to the other. So now, here's what we're going to get. What is 2 times 2? So you probably want to put it in the front. So I'm going to write it. I'll write it right here. 1 plus dy dx equals 4y dy dx square root of x plus y. Okay, I just multiplied, guys. I don't see any issues right now. Yep, we're good. So now what I'm going to do, what am I going to do? Yeah, I'm going to subtract the dy dx to the right, or move that dy dx to the right. So now I have this. I'll move it. I'll write it right here. 1 equals 4y dy dx square root of x plus y minus dy dx. Now what's my last move? Factor out a dy dx. So 1 equals, here's my dy dx factored out, parenthesis, 4y square root of x plus y minus 1. So sometimes you guys forget that. And then the last move, and I'll wait. Yeah, divide to get dy dx by itself. So dy dx equals 1 over 4y square root of x plus y minus 1. Now I know, because I've been seeing some of you guys write it, that Delta Math likes y prime instead of dy dx. That is fine, but I will caution you, sometimes y prime looks a lot like y to the first power. So be careful. I'm telling you, it's happened. I've been a reader for a long time now. It's happened where all of a sudden the kid confuses that and they think it's just y and they continue along, and now the expression is totally wrong. So I would caution you from using y prime into just using dy dx. Does that make sense? Yeah, there are a time and a place where maybe y prime is better, but I would, for now, when we get to those situations, we'll let you know. How do we feel? We feel okay? All right, so let's do this one, guys. It wants to know the second derivative at that point. So let's go ahead and start. There's a way to do this, like, well, you'll see right now. So I'm going to write the expression first. Xy equals 2 minus x. I got to do what rule in the left? Product. First times the root of the second plus second the root of the first. So there it is. You're done with that. Equals the derivative of the right-hand side. Negative 1. That's it. Make it into a dy dx. I know that's a second derivative, so move that to the right. So x dy dx equals negative 1 minus y. They're both negative, so minus will just... and now I'm going to divide by x, right? So dy dx equals negative 1 minus y over x. Are we still okay? Do you guys feel like factoring out a negative in the numerator, or you want to leave it like that? Doesn't matter to me. Leave it like that? Okay. So here we go. I'm going to take a second derivative. What rule do I got to do? Quotient. Bottom. Derivative of the top. What's the derivative of the top? Positive or negative? minus top, negative 1 minus y, times the root of the bottom, 1, all over bottom squared. Yeah. Don't try. Okay, this is just my suggestion. I would not try to substitute dy dx to solve. I would just plug right in. So I'm going to, Chop, what are you doing? What do you mean? So I'm going to first find dy dx. So dy dx evaluated at negative 1, negative 3. I would first find the value of this. And I'm just plugging in negative 1 minus a negative 3 over negative 1. What's that? 1 minus negative 3, so that's 2. So negative 2. So anytime I see a dy dx, I'm going to insert negative 2. Now I have a dy dx there, but notice I have a negative in there. So instead of negative 2, I'm going to plug in a positive 2. So here it is. So let me evaluate d squared y over dx squared equals, let me write the little line here. Line evaluated at negative 1 comma negative 3 is equal to negative 1 parenthesis and the negative 2. So I'm going to plug in 2. Is everyone okay with me plugging in 2? Minus parenthesis negative 1 minus a negative 3, so plus 3. Plus 3, right? Okay. Times 1, all divided by negative 1 squared. I think we're okay. All right, let's see what that is. So negative 2 minus, is that 2? Oh, you were giving me the answer already. 2 all over 1. So it looks like the answer is negative 4. So when you get to these on delta, don't try. Some of you are going to be like, oh, I'm plugging in dy dx and I'm trying to, guys, just make life simple. See what dy dx evaluated at that point, and then just plug in that value whenever you get to dy dx on the second derivative. Cool or not cool? Okay. These are the type of questions that you're going to see today on delta. I think I stole this one from delta. Negative 4xy minus 2 equals negative 2y to the fourth plus x cubed. Then find the equations of all tangent lines to the curve when y equals negative 1. Well, if I have a y value, what do I need for tangent lines? Point and slope. So I need to get an x value. So before you do anything, find an x. Negative 4, x, parenthesis, negative 1, minus 2 equals negative 2, parenthesis, negative 1 to the fourth plus x cubed. Are we still okay? All right. Negative times a negative is a... So I have 4x minus 2 equals negative 1 to the fourth power turns to a positive. Positive times negative 2 is a negative 2. Positive 1 times negative 2 plus x cubed. And let's see. The 2's go away. And I have 4x equals x cubed. So I'm going to divide both sides by x to get rid of one of them. So 4 equals x squared. So that means x equals plus or minus 2. And you can check it by plugging in the positive and negative 2 in here with the negative 1, see if it works. What was my expression? This one? 4 times 2 minus 2. Let's see if that's the same thing as negative 2 plus 2 to the third power. I'm just checking. Just checking. So 8 minus 2 equals, negative 2 plus 8. That checks. That works. I'm just checking. Now I'm going to check the negative 2. 4 times negative 2 minus 2 equals negative 2 plus negative 2 to the third. Yeah. Negative 8 minus 2 equals negative 2 minus 8. It worked. They both work. They're valid. Cool. All right. So here are my 2 points. Yeah, into this one. Because I already plugged in negative 1. You know what I mean? Here are my 2 points. My first order pair, 2 comma negative 1. And my second order pair, negative 2 comma negative 1. And if you want in a little bit, maybe we can use Desmos to see these tangent lines. Do you guys want to see that in a little bit? Yeah. No? Yes? Okay. Here we go. I need a slope, so I got to take a derivative, and I'm going to do it implicitly. So how do I do it? Group the 4x, the negative 4x, group those together. That way you don't have to worry, like, what's the first one, what's the second one? So here it is. First, I'm taking a derivative, guys. First times root of the second, what's the derivative of y? dy dx plus second derivative of the first, what's the derivative of negative 4x? Negative 4. I'm taking the derivative with respect to x, guys. The derivative of 2 is 0 or negative 2, so equals. And then what's the derivative of negative 2y to the fourth? Yep. Plus, okay, don't say this one. What's the derivative of x cubed? 3x squared. Okay. Here goes. I think we're good. Now we're done. We're just going to do algebra. So let's see. I'm going to move this guy. I guess let's make it pretty first, right? 4x dy dx minus 4y equals negative 8y cubed dy dx plus 3x squared. I'm going to move the negative 4y to the right of the equal sign. And I'm going to move the negative 8y cubed dy dx to the left of the equal sign. So I'm going to write the negative 8y cubed first because it's going to turn to positive. 8y cubed dy dx minus 4x dy dx equals 3x squared plus 4y. Let me know. I make mistakes all the time.
Where did the 2 go?
The derivative of 2 is 0.
Oh, yeah. Hello.
We're still okay, guys? Factor out a dy dx. And I'm going to have 8y cubed minus 4x equals 3x squared plus 4y. I still don't see any issues. I think we're okay. Yeah, it's very easy to make an algebra error. And now I'm just going to divide dy dx equals 3x squared plus 4y all over 8y cubed minus 4x. You're going to have to do this twice. Semicolon, dy dx evaluated at 2, negative 1 equals 3 times 2 squared plus 4 times negative 1 all over 8 times negative 1 to the third power minus 4 times 2. All I did was plug in, right? Let's see what that is. T squared is 4. 4 times 3 is 12. Minus 4 over negative 8 minus 8. Bless you, bless you, bless you, bless you, bless you. I don't know why I said so many bless yous. I don't see any issues. I think we're okay. So let's see. 8 over negative 16, negative 1/2, right? So here's my first tangent. Y, bless you. Y plus 1 equals negative 1/2 x minus 2. That's my first one. I'm going to do the other one in a different color because I'm running out of space. So I'm going to plug it in right here. Dy dx evaluated at negative 2 comma negative 1 equals, let's see, 3 times negative 2 squared, so that's not going to change there, plus 4 times negative 1 over 8 times negative 1 to the third minus 4 times negative 2. Oh, this is going to be a vertical line. Negative 2 squared is 4. 4 times 3 is 12. 12 minus 4 over negative 8 plus 8. Undefined. If you have an undefined dy dx, that means that you have a vertical line there. So a vertical tangent. So x equals negative 2 is I want to see it now. I didn't want to see it initially, but now I want to see it. Huh? Say it again. X equals negative 2 is your tangent line. Chav, why did x equals negative 2? Because you have an undefined slope, so that means you just have a vertical line. What's my x value? X equals negative 2. I want to see it because of that. So let's go. I'm going to go to Desmos, and let's see if we got this right or if we got this wrong. Oh, look, this is a picture of the San Antonio skyline taken from Woodlawn Lake this morning. Yeah, maybe I should have made that the hashtag. Let's see, Desmos. Give me the original equation, guys. Negative 4xy minus 2 equals negative 2y to the power of 4 plus x squared, x cubed. X cubed? Oh yeah, look at that. There's definitely, we did it right. X equals -2. Look at that at the point. Well, let me go ahead and write the points first. So give me my 2 points. It was 2, -1. And the other one was -2, -1. Okay, check out. You see those 2 points right there? The green and the purple dot? Look at this. X equals -2. Yep, that's definitely my tangent at that purple dot.
It just needs to touch
Well,
a slope on the line, right?
well, it's a point on a point, right? Because it's a point of tangency.
Wherever the point is.
Yeah. See? Boom. Point of tangency. Imagine that you're a particle traveling on this curve. And if you were right here at that moment, you're traveling on this curve and this curve were to disappear, you'd go off on a tangent. Just like Earth circling around the sun. If the sun were to disappear, it'd go off on a tangent. Do you know what I mean when I say that or no? Okay. What was the other tangent line? Y plus 1 equals -half. Let me put a negative. -half, parenthesis x minus 2. Yep, that's definitely a tangent line right there. Cool, right? What's up?
So, X is that like indicative of vertical asymptote or just
No, it's not a vertical asymptote because I don't have an infinite discontinuity. So it's just a vertical tangent. But sometimes it can be vertical asymptotes. So we got to be careful. So you can see the algebra was the issue. Well, if there's an issue.
algebra is always the issue.
All right, let's go to the next one. This one, if you read the language, it looks like it's coming out of delta because it is. If -xy minus 5 plus x equals -y cubed, and it is known, so they tell us it is known this. Find all coordinate points in the curve where y equals -1, and the line tangent to the curve is vertical, or stated no such point exists. Okay, well first what do I need for a tangent line? A point and a slope. They already have the derivative. I just need an x value. So let's see if I have an x value. So I'm going to write -x times -1 minus. No, I'm plugging it into the original. That's a curve. Right? Because I need to find an x coordinate. Okay. So -x times -1 minus 5 plus x. I didn't see that. Equals negative parenthesis -1 to the third. All right, so here's what I see. I see negative times the negative is a. So x minus 5 plus x. We'll combine like terms a little bit. -1 to the third is still negative. Negative times the negative is a positive. So let's see. 2x minus 5 equals 1. So now we can just move the 5. 2x equals 6. X equals 3. All right, if I know that x equals 3, let's see. What do they want? Find all coordinate points in the curve where y equals -1 and the line tangent to the curve is vertical. Okay, if my tangent line is vertical, what type of slope is that? Undefined. I'm going to check if at the point 3, -1, if I have undefined slope. If I don't have undefined slope, no such point exists. Does that make sense? All right, so here we go. dy dx, evaluated at, I need to be on the curve. What's up?
You said if you do have a defined slope, no point exists,
No.
or
Let me say that again. Because it's possible for this to be undefined, of course. But I'm trying to find a tangent line that is vertical. So if I'm going to be a tangent line, I need to be on the curve, right? Well, the only way that on this curve, so let's slow down. The only way that I'm going to be on this curve where y is -1 is if x is. So now that I have a coordinate, I'm plugging this into dy dx, and I'm going to see if I get undefined. If I do not get undefined, that I do not have a point on this curve. I do not have this point on this curve where I have a vertical. I don't have a vertical tangent at that point. I don't have a vertical tangent at 3, -1. Does that make sense? All right, here we go. dy dx evaluated at 3, -1 equals, let's see, -1 minus 1. Okay, fine. That's fine with the numerator. Denominator. -3, because it says a negative in front of that, plus 3 times -1 squared. Ooh, let's see. -3, -1 squared is 1. 1 times 3. So -3 plus 3, is that 0?
yes.
So I definitely have an undefined slope. Yep. So do they want and the line tangent to the curve is vertical or straight? Okay, it does. So the tangent is x equals 3. Yes. X equals 3 is a vertical tangent on the curve, and it's this one. Negative xy minus 5 plus x equals negative y cubed. Do you guys want to see that curve? Okay. This is why Desmos is so powerful. Close, 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 close. Okay, give me the curve, guys. Negative xy, that's all I remember. Minus 5 plus x. That's it. That's it. Okay, and what was the point of tangency? 3. Oh yeah, give me the point though. 3 comma negative 1. Yep, there it is. And check it out. X equals 3. There's my curve. It's a weird curve. Let's zoom out. Look at that curve. It's a little weird, but yeah. So obviously this is not a function, right? Because it doesn't pass the vertical line test. But it's a cool curve. I like it. Oh, you guys are not entertained? Look at all this entertainment value that you get every day. Oh, I get every day. Every day is different. There's no day that's exactly the same. Yesterday we were happy, and today we are happier. Oh, okay, I'll stop. Fall Fiesta. All right. Viva Fiesta. Viva Fall. Okay, that was dumb. Let's just do math. If x squared equals negative xy plus 2 plus y squared, and it is known that, so again, same type of problem. Find all coordinates on the curve where x equals negative 1 and the line tangent to the curve has a slope of 4/3, or say that no such point exists. Oh, this one's different. Let me read it again. So I have a curve, and it is known, there's my derivative. Find all coordinate points on the curve where x is negative 1, and the line tangent to the curve has a slope of 4/3. Okay. Yeah, so I have dy dx. It has to equal 4/3 for all coordinate points. Okay, well, the first thing I'm going to do is I'm going to plug in negative 1 in here to see if I can get y values. So negative 1 squared equals negative 1 times y plus 2 plus y squared. We're still okay, guys? All right, let's see what we get. 1 equals y plus 2 plus y squared. Okay, no big deal so far. I'm going to move the 1 to the other side, and I'm going to rewrite it. 0 equals, yeah, that's what I'm going to do. Y squared plus y, and then when I subtract 1, it's going to be plus 1. Oh, is this factorable? No, that's not factorable. It needs to be, and look, I have a 1 right here. It's not factorable. I mean, I guess I could go with my quadratic formula. Negative b plus minus square root of b squared minus 4ac all over 2a. So negative 1 plus minus, let's see if we get anything pretty. 1 squared minus 4 times 1 times 1. Nope, we get imaginary. 2 times 1. All right, abandon. Now let's get hints from here. So I need negative 1 minus 2x over x minus 2y to equal 4/3. Final corner points in the curve. Okay, let's multiply. So cross multiply. So I'm going to go like this. To get equivalent, like to get the left side equals something with the right side and see if we can find something. You know what I mean? Like to see if we can find something. Watch. 4x minus 8y equals negative 3y minus 6x. In order to get a slope of 4/3, I need this. Okay, I found it. We found it. See? So why did we do, so it's algebra. It's all algebra. Why did we have to mess with the dy dx? Because messing with the original got us nowhere. See, look, we got imaginary. We can't have imaginary numbers. We want real numbers. There is such a thing as complex calculus, but that's for graduate level math students. We're just high school kids. Are we still okay? So I have to go to my dy dx to see if I can find a relationship between x and y. And I did. I found one. Chop, what are you talking about? I'm going to get all the x's on the left. I'm going to get all the y's on the right. So I'm going to get plus 6x plus 6x. What's 6x plus 4x? 10x equals, and then plus 8y, 8 minus 3, 5y. And I have y. So then which one do I want to get by itself? I want to get, yeah, that's fine. Well, yeah, well, that's what I was going to do. I was going to solve for 1 and then see. Do you know what? Okay, here's what I'm trying to do, guys. Divide by 5, divide by 5. Y equals, so bear with me, get to here real quick. You'll see what I mean. All right, so let's not be robots anymore. Let me see if I can explain this clearly. The only way you're going to get dy dx to be a 4/3 is if my y value is twice of x. Does that make sense? So, no, okay. You see how I got y equals 2x? So that means that as long as I make my y value 2 times bigger than x, when I plug them in here, it's going to equal 4/3. I'm just going to make something up. It may not be on the curve, by the way. This is true for this. But remember, I also have to be true for, I can't see the curve. I also have to be true for the curve. Like, it has to be on this curve for it to be true. You know what I mean? No, okay. Let's just start with one part. If y is twice as big as x, this will give me 4/3. But just because it gives me 4/3 does not mean that that coordinate that I get here will be on this curve. Because look, you know what I mean? So I'm just gonna make this up. It might not be on the curve. I'm just making it up. If x is 1, y is, well, if I plug in 1 for x and 2 for y, I'm gonna get 4/3. Look, what was the value that I said? 2. So negative 2 minus 2, that's negative 4. 1 minus 4, and look, and there it is. Negative 4 divided by negative 3, 4/3. So what does this mean? As long as my y value is twice as bigger than x, it will give me a 4/3. But what do I gotta do? I gotta check that it's on the curve. Do I have a y value? No, they give me a y value. Oh, sorry, they give me an x value. Do I have an x value? Okay, what's my x value that I have? Okay, I'm going to plug in negative 1 in here, and I'm going to see what that y value is. So let's see. If x is negative 1, what's my y value? Negative 2. I'm going to check if this value, negative 2, is on the curve here. Chop, how do you check? Check if you get a true statement. Does that make sense? So here we go. I'm just going to plug in. Yeah. Ask. How? Do we see what we're doing or no? You can be honest. Oh. I'm just checking to see if I get a true statement. If I get a false statement, it's on the curve.
So the y value that you just found, the 2x, that's supposed to go out to the original?
Yeah. Well, I'm not going to plug in the expression because I think that's harder. You can do it that way too.
No, I'm just wondering. Like, that was...
I'm going to check to see that this coordinate that I just got makes this statement true. If it makes it false, it's not on the curve. So no such points exist.
But you're putting those values into the derivative or
the original? There's no reason to plug into the derivative. I already found the x and y. These points will make this derivative 4/3. As long as this statement is true, that y is bigger than x by twice, it'll only be true. I don't even have to choose negative 1, 2. I can choose any x and y value. This statement will always give me a 4/3. To get us a statement, to see how x and y relate. You don't have to do cross multiplication. If you want to do it the long way, multiply by the denominator, multiply by the denominator, get all the x's to the left, get all the y's to the right. I just thought cross multiplication was the easiest algebra, the fastest algebra. But we're good. Ask me, Henderson. Ask me. Oh, okay. Here we go, guys. I'm just plugging it in. Negative 1, negative 2. So negative 1 squared equals negative parenthesis negative 1 times negative 2 plus 2 plus, was it negative 2? Negative 2 squared. Let's just see if that's true. So 1 equals, like, well, it might be. No, it's not. Negative times negative is positive, but that's so negative. So negative 2 plus 2. Those cancel out. And look, nope, I get a false statement. False. No such point exists.
So then why did we
Yeah, these are going to take like 5 minutes each. So maybe I'll delete one of the, instead of 6 questions, I'll make it 4 questions because they're going to take 5 minutes. I don't know, but we can stay here as long as we want, I think. Okay. Luckily, that was the last one. Yeah, we just got to do one more, really. What's up?
If we had already known that it wasn't gonna work out when we started like factoring,
Well,
did it stop there, or like was it still like?
that's by chance. Like, what if it does? You know, like, yeah. Well, I mean, I guess maybe, yeah, maybe on this case, I guess if you want to save your time on this one, like, oh, I have negative exponents, that's not possible. You know what? It's not gonna even be possible. Not possible. So I think on this one, maybe you can look at it, and if you think about it enough, you can probably just say stop. But there will be cases where, you know, yeah, it could be you get something. You know what I mean? Yeah, this one's not as bad. Oh, this one looks like it could be bad.
Oh.
Yeah, I say not as bad, but see how it says second derivative? It looks like we're gonna have to do some substitution. Let's get it started and see how far we go. So we're taking the derivative. Ready? What derivative of negative 3x squared? Plus, and then what rule do I gotta use over here? Product first times derivative of the second. You're okay, miss. You're okay. Plus second times derivative of the first equals 0. Let's make it pretty. Negative 6x plus 2x dy dx plus 2y equals 0. Notice we're calm. We're going slow. We're not rushing. You can. You know what? Let's do that. Let's do what Houston says. Let's factor out a 2. Negative 3x plus x dy dx plus y equals 0. And then when you divide 0 by 2, that's, yeah, so negative 3x plus x dy dx plus y equals 0. Thank you, Houston. All right, move everything to the right that is not a dy dx. So x dy dx equals 3x minus y. Are we still okay? Divide everything by x. Dy dx equals 3x minus y divided by x. Now find the derivative again. What rule do I got to use? Quotient. Make sure your x's look like x's and your y's look like y's, because that might be the biggest issue. Second derivative, so d squared y over dx squared equals bottom, derivative of the top, 3 minus dy dx, minus top, 3x minus y, times derivative of the bottom, 1 all over bottom squared. We still okay? This dy dx right here, I'm going to substitute that expression. Don't worry, guys. I don't have a class in here, so x. What class you got? You got Kilgore? Yeah, don't worry about that class. Oh. Are you guys still okay? Let me know if we're falling behind. I'm going to distribute this x. So here's what I'm getting now. I'm going to get 3x minus, put a parenthesis because you're going to get it confused. Put a parenthesis right here because we got to distribute that minus. That x cancels out when I distribute. 3x minus y. So I'm going to turn that in a little bit. Minus, and yeah, I just, oh,
So it's just 3x.
3x minus, the x is canceled out.
Okay, I see.
I think we're okay. I think we're about to get the answer. Distribute. Yeah, sorry. 3x minus 3x plus y minus 3x plus y over x squared. So these right here, yeah, I might have gone too fast for my own good, maybe. Who knows? Maybe the answer is there. I think the answer is going to be in there. Negative 3x plus 2y, or maybe the other way around. Okay, is that answer in there? Yay! Okay, it was not a tricky one. How do we feel, guys?
Make